Hey guys, so this video is the answer key video for week 22 homework. Okay, so in this video, I'm going to talk about all the questions in week 22 homework. Okay, week 22. Okay, so let's look at question number 1. Identify the quadrant or axis where the point is located for each direction. So before we start doing this question, I want to review the Cartesian coordinates plane a little bit. Okay, so let's look at this graph first. Okay, so this is a Cartesian coordinates plane. This plane consists of two real number lines, which is called the x-axis and the y-axis. Okay, so remember, there are a few things that I want you to remember, okay, about Cartesian coordinates plane. First of all, this plane, this coordinates plane consists of two real number lines. So let me write here. So x-axis and y-axis are both real number lines. Okay, real number lines, by real number lines, we mean all the real numbers can be found on these two straight lines. Okay, number two, we know that the intersection of x-axis and y-axis, which is this point is called the origin. So origin is denoted by O. Has the coordinates 0, 0. Okay, so this point, origin, which is the intersection of x-axis and y-axis, this point has the coordinates 0, 0. Okay, and everything on the right side or above this point is positive, which means, so this part of the x-axis and this part of the y-axis, these two components are positive. And everything below the origin or on the left side of the origin is negative because they're real number lines, right? So for example, this point, okay? This point, if we go from origin 1 to 3, so x-axis, x coordinate is 3, y coordinate 2. So this point is 3, 2. Okay, so this is how we determine the coordinates of the points. Okay, and because of this feature, like because we have 4 parts in this coordinates plane, okay, we call these 4 parts 4 quadrants. Okay, and we call this the first quadrant. This is the second. This is the third. And this is the fourth. Okay, and because this part and this part, they're both positive, which means all the points in the first quadrant has the coordinates positive, positive. This means all the points in the first quadrants have positive x coordinate and positive y coordinates. Okay, and for second quadrant, we have negative x coordinates and positive y coordinates. So all the points in the second quadrant have negative x coordinates and positive y coordinates. Okay, with the same logic, all the points in the third quadrant has negative x coordinates and negative y coordinates. And with the same logic, all the points in the fourth quadrant have positive x coordinates and negative y coordinates. Okay, so this is a little bit of reveal of the Cartesian coordinates plane. Okay, these are the basic stuff that we need to know. So now let's look at the question. So it says, identify the quadrant or axis where the point is located for each situation. Let me draw this again here. So we have an x-axis, we have y-axis, and remember these are both real number lines. Okay, and we know this intersection is called the origin. Okay, and first quadrant, positive, positive. Second quadrant, negative, positive. Third quadrant, negative, negative. Fourth quadrant, positive, negative. Okay, so with the help of this graph, this question should be straightforward. Okay, so part A, x coordinate is negative, y coordinate is positive. X coordinate is negative. X coordinate is negative, so it's either the second quadrant or the third quadrant, right? Because only these two quadrants have the negative x coordinate, right? But it also says y coordinate is positive. So the answer should be second quadrant, right? Because only in the second quadrant, all the points have negative x coordinates and positive y coordinates. This is what the question is asking. Okay, let's look at part B. X coordinate is 0, y coordinate is negative. So now, when x coordinate is 0, which means we are looking at all the points on the y-axis, right? Because only on the y-axis, the points don't have an x coordinate, right? For example, this is 0, 0, this is 0, 1, 0, 2, 0, 3, 0, minus 1, 0, minus 2, 0, minus 3. So all the points on the y-axis don't have an x coordinate. This is what it means by x coordinate is 0. Okay, so the first part, this part is telling us we're looking at the y-axis. Okay, but it has another condition, which is y coordinate is negative. So we're only looking at this part of the y-axis. So we're looking at this part of the y-axis where the x coordinate is 0, also y coordinate is negative. Okay. So we're looking at, so the answer for this question is the negative part of y-axis. Okay, so this is the answer. Okay. 3, sorry, part C, x coordinate is positive, y coordinate is negative. So now we're looking at positive x coordinate. So positive x coordinate, we're only considering first quadrant or the fourth quadrant. Okay, and the second condition is y coordinate is negative. So we're looking at the fourth quadrant because only in the fourth quadrant, all the points have positive x coordinates and negative y coordinate. So the answer is fourth quadrant. Okay. Part D, x coordinate is negative, y coordinate is 0. So now we're looking at 0 y coordinates. So when we have 0 y coordinates, that means we're looking at x-axis because only on the x-axis all the points have 0 y coordinates. Okay, for example, so we're looking at the x-axis here because only on this axis, on the x-axis, all the points here don't have any y value, right? This is 0, 0. This is 1, 0, 2, 0, 3, 0, etc. And all the points here also don't have any y value. Okay, so we're looking at the x-axis. But it also says x coordinate is negative. So we're only looking at the negative part of the x-axis because only on this part of the x-axis, the points have negative x coordinates and 0 y coordinates. So the answer is the negative part of x-axis. Okay. E, x coordinate is positive, y coordinate is 0. Again, so x coordinate is positive, y coordinate is 0. When we look at y coordinate is 0, we're looking at what? X-axis again, right? Because only on x-axis, all the points on here have 0 y coordinates. But this time, okay, instead of negative x coordinates, we're looking at positive x coordinates. So these two questions are similar, right? The answer to question number, part E is the positive part of x-axis. Why? Let's look at this graph again. So we're looking at this part of the x-axis, only this part. Okay, so all the points on this part of the x-axis, they don't have any y value, which means the y coordinate is 0. Okay, also all the points on this part of the x-axis, their x value is positive. Okay, their x value is positive. So this satisfies both of the condition here, positive x coordinate and 0 y coordinate. Okay, last question. X coordinate is negative, y coordinate is negative. So we're looking at x coordinate 0 as our negative, y coordinate negative, 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 third quadrant. Okay, so the answer to F is the quadrant number 3. Okay, so this question basically is testing our knowledge of the Cartesian coordinates plane. Okay, so this question is about the coordinates plane. Okay. This is very important. Question number 2. Plot the points, join them in order to form a polygon. Identify the polygon. This shouldn't be too difficult, right? But let me quickly walk through the steps. Okay, so we know we should always start from the origin, 0, 0, right? And if the x coordinate is positive, we go right. If the x coordinate is negative, we go left. If the y coordinate is positive, we go up. If the y coordinate is negative, we go down, right? Okay, so let's do A. So part A, so this polygon has 4 vertices, right? A, B, C, D. And A has the coordinates of -2, 2. So we start from the origin. -2, the x-axis, sorry, the x coordinate is negative. So we go left by 2 units. So -1, -2, and we stop here, right? Now we look at the y coordinate, which is 2, which is positive. Because the y coordinate is positive, we go up by 2 units. So 1, 2. So this point over here, this point is A, which has the coordinates -2, 2. Okay, so this is how we, excuse me, this is how we find the points using the coordinates given. Okay, let's do B. Point B, -2, -2. Again, we start from origin. -2, which means the x coordinate is negative, we go left again. -1, -2. And again, from here, the y coordinate is also negative, so we go down by 2 units. -1, -2. So this point is point B, which has the coordinates -2, -2. Okay, and C, 2, -2, is this point. So 2, -2. So 2, -2. And this is point C. And D, 2, 2, 2, 2. So this is D, 2, 2. Okay, now we just need to join all the vertices. So this is what we do. And let's see. Let me draw a better graph. Okay, so now we joined all the vertices. We can see that the polygon is a square, right? This is a square. Okay, square. Let's look at part B. Part B, the polygon has 3 vertices, right? We don't even need to, we don't really need to draw the graph to know it's a triangle, right? Because it has 3 vertices, but let's try. So point A has coordinates 8, 1. So this is the origin, right? This is origin. And we go 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 1. So this is point A. This is point A. A1, right? And now we have 5 minus 4. 1, 2, 3, 4, 5. Minus 1, minus 2, minus 3, minus 4. This is minus 4. This is B, right? And then we have 10 minus 1. This is A, 9, 10 minus 1. C. And now we just need to join the vertices. Okay. And we can see that this polygon is a triangle. Okay, so question number 2 basically tests our skills of plotting the points. Okay, so we need to know how to read the coordinates and how to accurately find the points in the coordinates plane. Okay, so I would say question number 2 is relatively easy. Okay. Question number 3. Plot the points A, B, and C. Name a 4th point D so that A, B, C, D is a parallelogram. This question is a little bit tricky. So again, plot the points. Let's plot the points. Again, this is origin, right? This is origin. 8, 4, 0, 1, 2, 3, 4. This is A, right? B, minus 2, 0, minus 2, minus 1, minus 2, 0. So this is B, minus 2, 0. C, 0, minus 4, 0, 1, 2, 3, 4. This is minus 4. So this is C. So now we have 3 vertices of this parallelogram. We need to find where the 4th vertex is. Okay, so let's join the points first. We know it should be something like this, right? We know it should be something like this, right? But how do we find this point accurately? There are different ways, to be honest. I can tell you 2 ways of doing this. Okay, so now we have 3 vertices first. We have 3 vertices only, right? So let's look at this. Let's look at this side. Okay, so if we construct a right triangle, we can see, okay, so if we construct a right triangle, it should be like this, right? And both sides of the triangle has 1, 2, 3, 4 units. 1, 2, 3, 4 units, right? And this side, we start from point C. If we repeat what we have here on point B, then we have 1, 2, 3, 4 here, and 1, 2, 3, 4. So the point should be here, right? And then we can, so the point should be 1, 2, 3, 4, 1, 2, 3, 4. The point should be here. And now if we join these 2 points, this point should be D. And now if we join these 2 points, then this polygon is a parallelogram. Okay. There's another way of doing this, of course. So if you have, so let's say you're doing this question in your exam. It's easy, okay? You should have a ruler and you should have a pencil, okay? Basically, you use your ruler. So you measure the length of this line segment and push this line segment slowly to point B. And with the same length, you will find the other side of the parallelogram. Because for a parallelogram, these two sides should be parallel and they should have the same length. Okay, so you measure this side of the parallelogram and use your ruler, slowly push it to this point and then draw the line segment with the same angle and same length. And this will be your new side. This will be your new side. And you can see it reaches the same point, right? And now you join the last 2 points. And this is your point D. Okay, so there are different ways. Yeah, there are different ways. Both are okay. And I'm sure you might have like other ways of doing this too. Okay, so that's how I did this question. So this is how I found point D, and here A, B, C, D is a parallelogram, and we use this symbol to represent a parallelogram. Okay. Yeah. Okay, question 4. Plot 6 points. Plot 6 points where the y-coordinate is the same as the x-coordinate. Joined the points. What was formed is the relation linear. So plot 6 points where y-coordinate is the same as x-coordinate. So that means let's say, if we want x to be 0, then y has to be 0 too, right? If x is 1, then y has to be 1. If x is -1, then y has to be -1, etc. So let's just do -2, -2, -3, -3, -4, -4. Okay. If you see enough questions about linear relation, this is not even a question for you, okay? Because this is one of the most common linear relation. This is y is equal to x. Okay, this is a very, very common linear relation. It's a straight line that passes through the origin with a 45-degree angle. Okay, but if you have never seen this before, let's simply plot all the points in the coordinates plane and then join all the points. Then you will see it is a straight line. Okay. So 0, 0. We know 0, 0 is the origin, right? So let's call this point A, this point B, C, D, E, F. So this is point A. Point B is 1, 1, 1, 1. This is B. Point C is -1, -1. C. This is C. D is -2, -2, -2, -2. D. E is -3, -3. This is E. F is -4, -4. This is F. Right. So now we simply joined all the points. And we can see that this straight line over here it passes through all the points that we constructed, right? And we can tell that this is a linear relation because linear relation, like I said this many times, linear relation means straight line. So these two presentations are the same thing. Okay, so linear relation, linear expression, linear equation, whatever name we call it, this is the algebraic presentation of straight lines. And straight lines are the geometric presentation of linear relation. That means if we see a straight line, we know whatever expression that represents this straight line has to be linear. If we see a linear relation, we know the visual presentation of this relation must be a straight line. So the point here is we can tell this is a straight line, right? So the question says, describe what was formed. What was formed? A straight line was formed. So this is a straight line. Okay, is this relation linear? Yes, because it is a straight line, and linear relation and straight line are equivalent. So what was formed? A straight line was formed. Is this relation linear? Yes, it is linear. That's the answer to this question. Number 5, plot 7 points where the y-coordinate is the square of the x-coordinate. Use x values -3, -2, -1, 0, 1, 2, 3. Join the points. Describe the shape formed. Is this relation linear? Okay, so number 5, question 5. When you go to grade 9, I guess, I think you'll start learning quadratic functions. Okay, so question 5 is actually quadratic functions. So I can tell you the answer because we'll see that eventually. When the y value is the square of the x value, the formula is y is equal to x squared, right? Because here, the y value is the square of the x coordinate, x value. So this is not a linear relation. Okay. When we study linear relation, we said linear relation is of the form ax plus by plus c is equal to 0. And all the degree must be 1. Okay. All the degrees of the variables must be 1. But here, the degree of the independent variable is 2, it's not 1. So this is not a linear relation. Okay. And when we plot all the points in the coordinates plane, we'll see the shape is not a straight line anymore. Okay, this proves what I said. Linear relation and straight lines are equivalent. If a relation is not linear, then the geometric presentation of this relation is not going to be a straight line. Let's try. So when x is -3, y is the square of -3, which is 9, right? When x is -2, y is -2 squared, which is 4. When x is -1, y is square of -1, which is 1. 0, 1, 4, 9. Okay, so now we just need to plot all the points in the plane. So let's start from -3, 9. So this is 0, 0, 0, right? -3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think this is 9, right? 1, 2, 3, 4, 5, 6, 7, 8. Yes. So again, let's call this A, B, C, D, E, F. We have 7 points, right? And this is A, B, -2, 4. So we have -2, 1, 2, 3, 4. This is B. Okay, C, -1, 1. -1, 1. This is C. Okay, so for this, for the graph of this expression, okay, I'll tell you this later. Let's plot the points first. And then we have 0, 0, 0, 0, and 1, 1, 2, 4, and 3, 9. Okay, so if we join all the points, we'll have a graph that looks like this. So this is really hard to draw, so I might need to do some minor modification. Okay. Okay, this is kind of like cheating, but I need to show you what it looks like, right? So this is called, so this graph is the graph of, let's D, E, F, G. So this graph is the graph of y is equal to x squared. Okay, this function, this equation, or this function is called a quadratic function. Okay, and this graph is called a parabola. Okay, so when we talk about linear relation, we say the visual presentation of linear relations is a straight line. When we talk about quadratic functions, we say that the visual presentation of a quadratic function is a parabola. So they're one-to-one, okay? They're one-to-one mapping. So this is called parabola. So let's answer the questions. The question says, describe the shape formed. I mean, you can describe it, right? You can say it's a curve that opens up and there's like a minimum point and stuff. But you can simply say it's a parabola. Okay, you can simply say it's a parabola. So this is the name of this shape. This shape is called parabola. Is this relation linear? No, it's not linear because it's not a straight line. Okay, this relation is not linear. Is not linear. Okay, done. Next question. Question number 6. For the given finite equations, is the relation linear? How can we tell whether a relation is linear? Like I said, the standard form, we studied the general form, the standard form of linear relations last class, right? So we know it's ax plus by plus c is equal to 0. Okay, so the point here is in order for an expression to be linear, the degree must be 1. Okay, and a or b can be 0, but they cannot be 0 at the same time. Okay, so if an expression satisfies these two conditions, so degree of 1, AB can be 0, but they are not 0 at the same time, then it's a linear relation. Let's look at question A. Part A says y is equal to 4x minus 6. So we have a y to the power of 1, x to the power of 1, and the coefficient of x is 4, coefficient of y is 1. They're non-zero. So this is a linear relation, right? Question B, y is equal to 9. So the degree of y is equal to 1, right? And there's no x, which means so this means the coefficient of x is equal to 0, right? Plus 1 y minus 9 is equal to 0. So if we compare these two, so this is standard form, right? And this is the standard form of this question. If we compare the coefficient, we can tell that the coefficient of x is 0, which means a is 0, right? But b is not 0. And the degree is 1 for both x and y. So it also satisfies our conditions. So this is a linear relation. Okay. With the same logic, x is equal to 3. If we write this in the standard form, this is 1x plus 0y minus 3 is equal to 0, right? So here we have x to the power of 1, y to the power of 1. Coefficient of y is 0, but coefficient of x is not 0. So it satisfies our condition. This is a linear relation. Okay. The only non-linear relation in this question is part D. So this is not a linear relation. And this is, again, because this has a power of 2 instead of 1. This is a quadratic function. Okay, this is not a linear relation. And part E, again, we have 1, 1, degree of 1. And this is a linear relation. Okay. Question number 7. Given an intercept of a relation, what is one point in the relation? So I got a few emails from my students asking about this question. This question is actually it's very how to say that? It's a very straightforward question. Okay, but some people got confused because they didn't understand the word intercept properly. So what is XY intercept? Let's draw a graph. Okay, so we have X and Y, right? Let's draw a random straight line. Let's say the straight line goes like this. Right? So let's call this L. So this is straight line, right? What is the X and Y intercept? So the X intercept is the intersection between the straight line and the X axis. So this point is called the x-intercept. Okay, and with the same logic, the straight line and the y-axis, the intersection here, this is called the y-intercept. Okay, so now after we visualize this, we can see it doesn't matter like what the straight line looks like. The x-intercept always have the form x0, which means the y value is always 0 for x-intercept, because the x-intercept is always on the x-axis, right? Because the x-intercept is the intersection of the straight line and x-axis. So the point here, it's always on the x-axis, which means the y value is always 0. Same logic. Y-intercept always have the form 0y, which means the x value is always 0, because the y-intercept is the intersection of the straight line and the y-axis, which means the y-intercept is always on y-axis, which means the x value is always 0. Okay, so after like understanding what x, y intercepts are, we should know how to do this question. Okay, so the question is basically asking, if I have an x-intercept 5, what's the coordinates of this point? If I have an x-intercept 5, y is always 0. So the point is simply 5, 0. That's how easy it is. When we have a y-intercept -6, okay, y-intercept, I mean, this graph, like this graph is not accurate, but like it explains the logic, right? So when we have an y-intercept of -6, the x value is always 0, because this point is always on the y-axis, because it's the intersection of these two lines, right? So when we have a y-intercept -6, the point, the coordinates of the point, it should be 0, -6. Okay. If we have an x-intercept 0, if the x-intercept is 0, that means the straight line and the x-axis, the intersection is 0, right? And we know that all the x-intercepts have the y value of 0. So this should be 0, 0, right? If we have an x-intercept 0, that means the straight line passes through the origin. If we have a y-intercept 3.6, again, when we have y-intercept, x is 0, so 0, 3.6. So that's why I said this question, it's a very, very easy question. A lot of people didn't get it because they didn't really understand what x, y intercepts are. Question number 8. Graph the relation defined by the given equation, make a table of values of 5 points and draw the graph. So graphing questions, we take different x values and we find y values, and then we plot the points and we join the points. That's what we do. So the expression is y is equal to minus 3x minus 1. When x is minus 2, y is equal to, so when x is minus 2, y is equal to minus 3, minus 2, minus 1, right? So minus 3 times minus 2, and this product minus 1, which is equal to minus 3 times minus 2, that's 6. 6 minus 1, that's 5. So this is 5. Okay. Minus 1, when x is minus 1, minus 3 times minus 1, that's 3. 3 minus 1 is 2. 0, minus 3 times 0, that's 0. 0 minus 1 is minus 1. And that's minus 4. And 2, that's minus 7. Right. So now let's plot all the points. This is origin. Minus 2, minus 5. Minus 2, oh, sorry, minus 2, positive 5. So minus 2, 1, 2, 3, 4, 5. This is the first point. Minus 1, 2. Minus 1, 2. 0, minus 1. 0, minus 1. Here, right? 1, minus 4. 1, 1, 2, 3, 4, minus 4. And 2, minus 7. 2, 1, 2, 3, 4, 5, 6, 7. Here. So if we did the calculation correctly, when we joined all the points, they should be all on the same straight line. Okay, looks like we did a good job. So see, this is the straight line we're looking for. Okay, and the points, let me use an ugly color. So this is all the points that we found in the chart. Okay. 1, 2, let's see, 1, 2, 3, 4, 5. Minus 2, minus 1, 0, minus 1, 1, minus 4, 2, minus, oh, here's one more. So these are the 5 points that we found. Okay. Question number B, sorry, part B. X over 3 plus 1 is equal to y. So when x is equal to minus 6, okay, let me give you an example. So when x is equal to minus 6, minus 6 over 3 plus 1 is equal to y. Okay, so minus 6 over 3, that's minus 2. Minus 2 plus 1, that's minus 1, which means y is equal to minus 1, which means here it should be 1 minus 1. So the point is minus 6 minus 1. Okay, give me 1 second, please. Okay, so let's continue looking at this question. When x is minus 3 over 3, that's minus 1. Minus 1 plus 1, that's 0. So here it should be 0. Okay. When x is 0, 0 minus 0 over 3, that's 0. 0 plus 1 is y. So y is equal to 1. Okay. When x is 3, 3 over 3, that's 1. 1 plus 1, that's 2. When x is 6, 6 over 3, that's 2. 2 plus 1, that's 3. So what we did here basically is we chose different x values and we found the y values. Okay. So now let's plot all the points in the plane. Okay. So minus 6, minus 1. So again, this is the origin. Minus 6, minus 1. 1, 2, 3, 4, 5, 6, minus 1. So it should be this point, right? We have minus 3, 0, 1, 2, 3, 0 here. That's the second point. 0, 1, 0, 1, right? We have 3, 2, 1, 2, 3, 1, 2, 6, 3, 1, 2, 3, 4, 5, 6, 1, 2, 3. So these 5 points are found based on the calculation of this expression. So if our calculation is correct, when we join the 5 points, they should be all on the same straight line. Okay, so it looks like we did it right. Okay, so this straight line is the one that we found. Okay, so the question says graph the relation defined by the given equation, make a table of values of 5 points and draw the graph. Yeah, so this is what we need to do. This is what we need to do for this question. Okay. Okay, guys, so it's getting late. It's 2 a.m. So I'm going to stop here. This will be the first part 1 of the homework answer key video. Okay, and I will make the second part of the video tomorrow when I have time. Okay, so you guys can study this video first, and you can expect the second part video maybe by the end of tomorrow. Okay, so I will see you on Saturday in class.